Hey everyone and welcome back. Today we're going deep on something most people probably haven't even heard of, but it's affecting us all.
That's right.
Inertial navigation, but with a deep learning twist.
Uh-huh.
So inertial navigation on its own, that's how things like smartphones and drones
Yeah.
know where they are without using GPS, right?
That's right. Yeah. They use these little sensors
Okay.
called accelerometers and gyroscopes, and those measure acceleration and rotation.
So it's like a little internal compass
Pretty much.
and speedometer all in one.
Yeah. Yeah, exactly. Tracks every twist and turn.
But the thing is, these sensors, they're not perfect.
No.
They have this thing called drift,
Uh-huh.
where like small errors in the measurements
Yeah.
add up over time and they throw off the position right.
Exactly. Like imagine you were walking in a straight line, but you
What?
slightly miscount your steps.
Yeah.
After a while, you'd be way off.
Yeah, you'd be way off course.
Yeah. And that's the challenge even with the most precise sensors. They have tiny imperfections.
Right.
And when you integrate all those measurements to figure out where you are, those tiny errors become big ones.
I see, so it really snowballs.
Yeah, it really does. And there are two main types of errors. We got what are called deterministic errors,
Okay.
which are basically like a consistent bias or a scaling issue in the sensor.
So like if your compass is always off by like 5 degrees or something.
Exactly.
Okay.
And then there are random errors, which are basically just noise, unpredictable stuff.
So it's like a wonky compass that's also got the jitters.
Pretty much, yeah.
Gotcha.
And traditional ways of dealing with that drift have kind of struggled with these issues. Like we've got pedestrian dead reckoning
Okay.
that uses like the cyclical motion of your steps,
Interesting.
or zero velocity update, which uses moments when you're standing still to
Yeah.
try to recalibrate.
Interesting.
They're helpful, but they don't do well with complex movement or unpredictable environments.
Okay, so that's where this deep learning stuff comes in.
That's exactly it, yeah.
I'm really curious to hear how it's shaking things up.
Yeah, so what's really amazing is how deep learning can take huge data sets and learn these really complex patterns.
Okay.
So we feed these algorithms tons of IMU data,
Right.
and they figure out how to fix that drift in ways we couldn't do before.
So instead of us figuring out some fancy new formula, we're letting the algorithms learn by doing.
Exactly. And it's kind of like how our brains work, right?
Yeah. Learn from experience.
Yeah, exactly. And what's even more exciting is deep learning isn't just a one-trick pony here.
Okay.
It's being used at multiple stages.
Gotcha.
And that's what's making inertial navigation more accurate and adaptable than ever.
Okay, I'm hooked.
Yeah.
Break it down for me. How is deep learning being used at these different levels?
So first off, we're talking about the sensor itself. Imagine using deep learning to personalize a noise filter for each individual sensor.
Interesting.
The algorithm learns the specific quirks of that sensor and fixes biases and noise right at the source.
Before the data even gets used.
Exactly.
Wow, that's pretty clever.
Yeah.
So are we saying we could start using cheaper, like less accurate sensors
Potentially.
and still get good results?
That's the potential, yeah. By calibrating these cheaper sensors with deep learning, we could open up a ton of new applications.
Yeah, like where cost was an issue before.
Exactly. Like imagine your phone using just its built-in sensors for indoor navigation, or drones that are way cheaper because they don't need high-end IMUs.
That's really cool.
Yeah.
So we tackled the sensors. What about the actual algorithms themselves? How's deep learning improving those?
So traditional algorithms use math formulas to take sensor data and estimate position.
Okay.
Deep learning can actually improve those. Right. Or even replace parts of them entirely.
Really?
Yeah. For instance, instead of using double integration of acceleration to get velocity, which is really prone to that drift,
Yeah.
we can use deep learning to estimate velocity straight from the sensor data.
So it's like we're giving those algorithms a shortcut.
Exact.
Bypass the messy parts.
Yeah, and deep learning can even auto-tune things like noise parameters and a Kalman filter.
Okay.
Those filters are crucial for combining different sensor measurements.
Right.
But they're tricky to set up. Deep learning can automate that.
So it's making things more adaptable.
Exactly. More adaptable and robust.
Gotcha. So we've got the smarter sensors, smarter algorithms. What's that third level you were talking about?
That would be the application level, where we tailor deep learning to very specific navigation tasks.
Okay.
So think about indoor navigation on your phone. Deep learning can analyze how you walk and create a kind of motion fingerprint.
Oh.
So you get more accurate pedestrian dead reckoning. Your phone can pinpoint you even inside a big building without GPS.
So it's learning my personal walking style to navigate.
Exactly.
That's so cool.
Yeah.
I think I read about a project that did that. NILOC, right?
That's a great example. And NLog and others are really showcasing what deep learning can do for indoor positioning. And it's not just smartphones either.
Oh, right.
There's exciting stuff happening with drones, robots, even self-driving cars. Deep learning is making inertial navigation work in places where GPS is unreliable or just doesn't work at all.
So this is all sounding pretty incredible. It feels like a huge leap forward for inertial navigation. But before we get ahead of ourselves, maybe let's hear some concrete examples of how these advancements are actually playing out. What kind of results are we seeing?
Yeah, absolutely. There are some really impressive results starting to come out of this research.
Okay, great.
The one that's really caught people's attention is IONET.
IONET, okay.
This system's doing amazing things for pedestrian tracking.
What's so special about it?
Well, using just the IMU data from a smartphone, IONET can track someone's movement accurately for minutes at a time.
Wow. So like my phone could guide me through a giant mall or an airport without needing GPS or Wi-Fi.
That's the idea, yeah.
That would be pretty handy.
And wandering around lost.
Exactly.
Okay.
What else? So then we've got TLIO. That stands for Tightly Learned Inertial Odometry.
Tightly learned what?
Inertial odometry.
Okay. TLIO.
It's a mouthful.
It is. So what's TLIO doing?
It's making big waves in VR, using deep learning for super precise 3D localization.
For the VR headsets, you mean?
Yeah. Imagine moving in a virtual world and it feels totally real because the algorithms are nailing your position down so accurately.
That would be amazing. No more of that clunky movement you get in VR sometimes.
Exactly. Makes it way more immersive.
Definitely.
And these are just a couple of examples.
Yeah, I bet. The research is just exploding in this area. Autonomous vehicles, drones, robotics, it's all happening. Imagine cars driving through tunnels perfectly.
Wow.
Or drones delivering packages without GPS.
All thanks to this stuff.
Exactly. Deep learning is making it all possible.
It feels like a whole new world.
It really does.
But deep learning isn't just about making inertial navigation better by itself, is it?
No, you're right. It's also changing how we combine IMU data with other sensors.
Right, sensor fusion.
Exactly.
Like we're taking the strengths of different sensors to make something even stronger.
Yeah, like assembling a superhero team.
I like that.
Each sensor brings its own unique skills.
So we have the IMU giving us motion and acceleration. What other sensors are in the mix?
Well, cameras and LiDAR are two of the big ones. Cameras provide visual information.
Okay.
And LiDAR uses lasers to make these detailed 3D maps.
Right.
Combine those with IMU data using deep learning, and we get a way richer understanding of the environment and much more accurate positioning.
It's like we've got eyes, laser vision, and a super sense of movement all working together.
Exactly.
So are there any examples of how deep learning is making sensor fusion better?
Oh, tons. One really interesting area is self-supervised learning in visual inertial odometry, or VIO.
Yeah, okay.
So here, the system actually learns from the data itself. We don't need all that expensive ground truth labeling that traditional systems need.
So it's like the system's teaching itself.
Pretty much, yeah. Think of a drone flying through a forest using its camera and IMU to navigate.
Okay.
With self-supervised learning, it can learn and adapt on the fly, getting better and better at navigating without any help from us.
Wow, so it's like it's building its own map of the forest as it goes.
Exactly. And I remember you mentioned deep TIO earlier.
Oh yeah, GTIO.
That's another perfect example of how deep learning and sensor fusion can solve real problems. It combines thermal images with IMU data, so firefighters can navigate through smoke where they can't see anything.
That's amazing, like something out of a movie.
It is, but with real-world life-saving applications.
Absolutely. So the sensor fusion stuff, it's not just for navigation, right?
Right. We talked about human motion analysis and activity recognition earlier.
Yeah, we did. It's like we're using those same sensors that track movement to understand what we're doing, even how we're feeling.
Exactly.
So tell me a bit more about those applications.
Well, in human motion analysis, deep learning is being used to create these crazy, realistic digital versions of people moving based on motion capture data.
So that's how they make those awesome special effects in movies and games.
A big part of it, yeah.
That's so cool. And what about activity recognition?
So there, deep learning can look at data from things like smartwatches
Okay.
and fitness trackers
Uh-huh.
and tell what someone's doing. Walking, running,
All
sleeping,
right.
even more subtle stuff. And this is huge for healthcare. Imagine doctors being able to keep tabs on patients' activity remotely
Yeah.
or spot early signs of problems with how they're moving.
That's incredible. All this from these little sensors.
I know, it's mind-blowing.
It really is. It feels like we're just at the beginning of what's possible.
Oh, absolutely.
Any predictions for the future?
Well, this field's changing so fast.
Right.
What we see now is just a glimpse. New breakthroughs are happening all the time. Imagine using motion as a unique ID,
Okay.
like a fingerprint, or predicting health issues based on tiny changes in how someone walks.
Wow, that's pretty mind-blowing.
It makes me
Makes you wonder what else is coming down the pipeline.
Uh,
Yeah, it really makes you think those tiny little sensors we barely notice
yeah,
could be so much more than just a way to find our way around.
right.
This whole deep dive has been eye-opening for me. Inertial navigation plus deep learning, that's a powerful combo.
It really is. Deep learning is so good at finding those patterns, even in this really subtle and complex data from these sensors.
Right.
And it's changing everything, not just navigation, but how we understand movement itself.
And it's not just about the tech itself.
Right.
Like, it's the impact it can have.
Exactly.
We talked about self-driving cars, firefighters, and smoky buildings.
Yeah,
It could make the world a safer place.
absolutely. And don't forget healthcare. Imagine spotting those tiny changes in how someone walks.
Yeah.
That might mean something's wrong neurologically.
Right.
Or using movement data to build personalized rehab programs.
Wow, that's incredible. Using movement to understand our health that way.
Yeah.
Well, we've covered a lot of ground today. From how deep learning makes sensors better to all that mind-blowing sensor fusion and activity recognition stuff.
It's been a journey.
It really has. Any final thoughts for our listeners out there who want to learn more about this?
I'd say the biggest thing to remember is this field is changing so fast. What we talked about today is just a snapshot.
Yeah, just scratching the surface.
Exactly. So keep your eyes peeled, follow the research, maybe even get involved yourself. Who knows? You might be the one who comes up with the next big thing.
That's great advice. There's so much potential for innovation here. Well, thanks for joining us on this deep dive, everyone.
Yeah, thanks for having me.
We hope you enjoyed it as much as we did. Until next time, keep exploring and stay curious.